welcome to Khetz tutorials, and in this video I'll be covering the remainder and factor theorems. So let's get right into it. So starting with the remainder theorem, just gonna write this for short because okay. So the remainder theorem says that if a polynomial, so basically a polynomial is just an expression that has many terms. So let's say a polynomial f of x is divided by some linear polynomial. So this lines for division, or we can write it in this way. So if f of x is divided by some linear polynomial x plus b, and by linear we're basically saying that the highest power in the expression is 1. So that x has a power of 1, so that is what is meant by linear. So this theorem only applies when you're dividing by a linear polynomial. So now the a would be the coefficient of your x, and the b would just be a constant, a number, 7, -7, any integer basically. So now that we have this, the theorem says that if you divide f of x by this linear polynomial, then the remainder that you expect from that division would be r for remainder, is equals to f of negative b divided by a. And this b would just be that constant that we talked about, and the a would just be the coefficient of x. So whatever equation that you have, for example, let's say you have this, then to find the remainder when dividing f of x by this linear polynomial, you basically just put a negative sign, then put whatever you have, which is -2 in this case. So you carry that whatever sign that it has. It doesn't necessarily have to take on this form. So you just carry on whatever sign that it has. In this case, it has -2. Then you're going to take the coefficient of x. In this case, we have 3. And that would be the value. This value in here would be the value that you actually substitute into f of x. So the result will be f of 2/3. So now, this basically means that wherever you see x in your f function, you'll substitute this value, and then after substituting that value, you should get some sort of value, right? Which would be your remainder, and that is the basic principle of the remainder theorem. So now, to put all of this into perspective, I'll just go through an example, and there's not much to talk about, or there's not much to look at with regards to everything that I'll talk about today. And the questions that will come are basically variations or applications of the content which I'm basically talking about. So just to do an example, let's look at an example. So let's say our f of x is x squared subtract 2x subtract 8. And we want to find the remainder when dividing by x plus 2. So we're saying that this f of x is divided by x plus 2. So what is the remainder when you do that division, right? So if you recall from our remainder theorem, we basically have to put a negative sign, take b, which is 2 in this case, and then take the coefficient of x, which would just be 1 in this case. So this is what you have, and you substitute this value into f. And doing that, you basically have f of -2. And now putting that into there would give you a remainder. So now the answer would be found when you basically substitute this value. So substituting the value -2 into the f equation. And the answer, once again, I'm saying this a couple of times now, would be the remainder. So the question asks for the remainder if you were to divide by this linear polynomial. And this is what we're doing. This is what we're basically trying to find right now. And here you basically have 4. Here you'd have 4 as well. Then subtract that, and your answer is 0. Now, in some other cases, you'd have a non-zero answer, or your answer won't be 0, and that would be your remainder. In this case, when you have a remainder of 0, this means that this value that you use to divide is actually a factor, right? So I'll give a practical example with just something like 4 divided by 2. Now, if you say 2 into 4, you basically get 2, right? But if you try to compute the remainder here, there is no remainder because you can fit 2 exactly 2 times into this 4. So once you get a remainder of 0, it basically means that whatever value or whatever factor that you use to divide is a factor. And that leads us to the factor theorem. So let me just open a new page. Right, let's now talk about the factor theorem. And I'll do another example that talks about the remainder theorem. I'll do about 2 more examples or so. I'll see. So now let's talk about the factor theorem. If you remember from the previous example, we found our remainder to be 0. So now if you have a remainder of 0, it means that whatever factor that you divided by fits exactly into the value that you are trying to divide into, right? If that makes sense. And now the factor theorem has 2 points which basically say the same thing. And one of them is that if f of x is divided by, so we're basically coming back to that thing which we talked about when we were talking about the remainder theorem. Now if you do this division and the remainder that you find is 0, then this means that this ax plus b is a factor of f of x. And once again, to put this into perspective, this is what I mean by this. So if you solve a polynomial, let's say this is a quadratic polynomial, maybe something x squared, or even a third order polynomial. So let's say you have something like this, and you equate that to 0. You should expect to get 3 brackets, right? And from these 3 brackets, you basically have the factors that make this thing up. So that is what is meant by factors. So if you divide f of x by some linear polynomial and your remainder is 0, then this polynomial is a factor of the f of x. So that is what is meant by that, right? So you can swap this thing around. And the first point, as I said, there are 2 points which basically say the same thing. So if f of x is a polynomial and ax plus b is a factor, then you expect your remainder to be 0. So if f of x is a polynomial and ax plus b is a factor, then the remainder that you expect is 0. And the second point says that if you find a remainder, so if you compute the remainder and you find a remainder of 0, then it basically means that ax plus b is a factor of f of x. So this works in 2 ways. So depending on whatever you find first, then you basically have the same conclusion, which boils down to the fact that a remainder of 0 means that whatever you are dividing by is basically a factor. So now let's continue with some examples. I have repeated myself quite a lot, talking about the content and how you'd basically apply it. And in maths, one good way to go through stuff is to do examples. Let's do another example. And in this example, you have to apply the same theorem, basically the remainder theorem, but it has been swapped around in a way to test if you actually understand what we have been talking about. So let's say you have a polynomial which is of this form, and this is a, right? And don't confuse this a with the a in the linear polynomial. This is just a variable. It could have been any other value. It could have been z, it could have been k, whatever variable, right? And yeah. So let's say we have this polynomial and we're told that the remainder is -6 after dividing by x plus 2, right? So we're dividing by x plus 2. So we want to basically divide the top polynomial by this x plus 2. And we're told that the remainder after doing that is -6. Let's go back to the theory. Using the remainder theorem, we have to take this, which is 2, we have to negate that. Then we have to take the coefficient of x, which is 1 in this case. Then we have to substitute this into our polynomial that we're dividing into. And this will give us our remainder. So we know that this f of minus 2 will give us the remainder. But now in this case, we're given the value of the remainder, right? And we're told that it's equals to minus 6. So we know that if we substitute f of minus 2 into this f of x, we should get minus 6. But if you look at this formula or this polynomial, it basically lacks this coefficient over there. And that is what the question is asking for. So it's the same thing, but they are asking for a different thing. In the previous question, we found the remainder. In this question, we're given the remainder, and we're asked to find one of the coefficients of the actual polynomial that we're dividing into. So it's the same thing, just that we're finding a different variable or a different value in using the same theorem, right? Okay, so let's continue. Now we just have to substitute, just as we would substitute that minus 2 into our f of x. And this is basically us calculating the remainder, but we already have the value of the remainder, which is minus 6. So all that we have to do is to answer the question and basically find this, which is a, and that is what we're looking for basically. So now doing that, to basically have, let's just simplify all of this and try to solve it quickly. Minus 6, and this would be minus 40, this would be 12. That would be 2a, that would be 4, and minus 6 on that side. Don't forget that negative sign. And on the left, you have 2a. On the right, you'd have negative 6 plus 40. You can actually add it up if you like, before we actually take it to this side. So on the left, it would be negative 28, and then add that to 4, it would be negative 24. And taking it to this side, it would basically be plus 24. And now we have that, and this would be 18, and dividing both sides by 2, your a would then be 9. And that is what the question was asking for. We've now answered the question. Given the remainder, and given something which is a linear polynomial that we're supposed to divide by, and given f of x, we are supposed to find a variable in the equations. And you basically use the remainder theorem to do that. So just make sure that you know the remainder theorem and you know what you're supposed to do when you have a linear polynomial as well as a polynomial that you're supposed to divide. Now I'm going to move on to the last example before we close off this video. And in this example, we have x cubed minus 6x squared plus 11x subtract 6. So let's assume, or let's say this is our f of x, right? And the question says, prove, no, that's not what the question says. It says f of 2 is equal to 0, okay? And then it says solve for x if f of x is equal to 0. So using basic algebra, you could just basically skip this information and just go on to this and actually factorize or see how you can actually find all of the factors and stuff like that. But since we're talking about the remainder theorem, factor theorem, and stuff like that, this is actually useful information to us because we want to solve this f of x is equal to 0. And we already have a value that will give us that 0 that we're looking for when substituted. So when we substitute, we know that when we substitute 2 into this equation, we are going to get 0. So that should be, or this should be, one of the factors that we're actually looking for. Now in terms of writing this would be x minus 2 because we have 2 other factors that we have to find, which is also part of the question. So the question in full is basically this. We're supposed to find all of the factors. Since this is a third order polynomial, we expect to have 3 factors. So we're supposed to find all the factors that are going to lead to 0, or which are basically the roots of the equation. So one of them would be x equals to 2, because as you can see that if we substitute 2 over there, we've already been told that it leads to 0. So given that information, in terms of a linear polynomial, this is how you'd write it. So that is how one of the factors, so x minus 2 is one of the factors that we're actually going to use. And the method that I actually used is long division. I'm not quite sure how you do it, or whichever method that you're comfortable with, basically. But the fact of the matter is that one of the factors is x minus 2, and you're supposed to find out the other factors. So now doing this, you basically put your, so this is my long division method, and yeah, I'm just going to explain how you do it using long division. So this point basically tells you that x minus 2 is a factor. So you'd have 2 more factors, but this, which would lead to x equals to 2, which is the same thing as that, is a factor. So now doing our long division, here's how you'd basically do it. So you'd look at the state of your factor that you're trying to divide by, and you'd see that that is x with a coefficient of 1 and a power of 1. So to get this first one, so you basically first look at the first one. To get that, we know that we have to multiply this first one by x squared. We don't really look that much into the other things that follow, but start with your highest power of x, which is just 1 in this case. So now we now are going to multiply this whole expression with x squared. Even though we use just this 1x to divide into x cubed, we're going to multiply everything by this x squared. And doing so, basically we'll have x cubed minus 2x squared. And now you just have to subtract. And here you basically have minus 4x squared, and this will cancel out, right? That will just be 0. Then you're going to take this down here, and you're going to continue the same method, now taking this and seeing how you can make it that. So to do that, you basically multiply by negative 4x, and multiplying by negative 4x, multiplying this by negative 4x, now you have negative 4x squared plus 8x. And continuing once again, subtract the 2, and you'd have, over here you basically have minus 3x. Is that what you'd have? Let's see, this is 11 minus that. It's actually positive. So it's 11x minus this 8x, so that is positive 3x. And these two just cancel out, minus 4x squared minus this would be plus, and then with that it basically cancels. And once again we take this down, and finally we are going to see how we can make this x, or basically transform this x into that 3x, and to do that just multiply by 3, a positive 3. So that will be our answer, or other factor at the top. And now multiplying the 3 with this expression, we'll have 3x minus 6. And subtracting the 2, we just have 0, which means we are basically done and we don't have any remainders. And that confirms that this is actually a factor, because in the end we have a remainder of 0, right? So that is one way that you'll actually do this. And we now have our factors which make up the original equation. So this is how you write these two. And now you equate them to 0, because that is basically what the question was asking for. So the question basically gave you one of the factors, and all that you have to do is to find these other 2 factors. This is a second order polynomial, so you expect to get 2 more factors from there. And you're basically going to do that just by factorizing. So if you factorize to find the other 2 factors, you should get something like this. And these are your 2 factors, and you'd have x equals to 2, or x equals 1, or x equals 3. And that is basically how you answer that question. That is the reasoning behind your remainder and factor theorem. They're basically linked, and you just have to understand the remainder theorem and how you basically use it given factors and how you use it given linear polynomials and whatnot, basically. So that is all from this video. It's quite long, but I do hope that you got some value out of the video, and if you like it, just go ahead and give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.